Today we will look into slope-intercept form, and we will graph with the slope-intercept form. Slope-intercept form is a way to find out solutions for a linear equation by graphing. Remember, the graph is a visual representation of all possible solutions. We have a couple of steps that we're going to go through. First one is we will rewrite the problem in y is equal to mx plus b form. Then we will identify the slope and the y-intercept in the equation. Finally, we'll graph by plotting the y-intercept first, and then finding more points, more solutions, by moving the slope. We will see a couple of different types. You may see an already written slope-intercept form. It will already be in y is equal to mx plus b style. We might see an equation where we might have to solve for y first. And we will also see special cases such as Hoy and Vox. Here's our vocab. Make sure to copy this down as well. Slope-intercept form is a linear equation written in the y is equal to mx plus b form, where m is the slope and b is the y-intercept. Y-intercept is the y-coordinate of a point where the graph crosses the y-axis. This is the slope-intercept form. In this form, y is the y-coordinate, m is the slope, x is the x-coordinate, and b is the y-intercept. Here's our first example. This example is already given in slope-intercept form, where our slope is -2 and y-intercept b is 5. Having slope -2 means our slope will be -2 over 1, which is down 2 and over 1. Y-intercept 5 means this is an ordered pair on the graph. When x is 0, y is 5. So on the y-axis, I will find my y-intercept as 5. At this point, our x value is 0, y value is 5. Now we will move with the slope. Slope is -2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. These would be the additional points. Now we can graph our equation by connecting the solutions. Equation of this line is y is equal to -2x plus 5. Let's also do a check step here. If we look at the points 0, 5, we can find other points. In order to do a check step, I can select one of the points, one of the other points at random. I chose 2, 1. It's an order pair where first one is x value, second one is y value. We will substitute this value into the original equation, where we would have y is equal to -2 times x plus 5. And once we evaluate this, we should get a true answer. Since this statement is giving us a true answer, that means the point 2, 1 was a solution to this system, which confirms that our graph was correct. If you end up with a false statement, that means either our y-intercept or the slope might have been incorrect, so we would have to trace back and check our work. Here's your first try. Our next example will require us to rewrite the equation in slope-intercept form. To rewrite the equation, I need to leave the y value alone. So let's subtract 6x from each side. Subtract 6x from each side. We will have -3y is equal to -6x minus 9. We will divide each side by -3. Y is equal to -6x minus 9 over -3. Let's separate this into two fractions as well. Then we will have y is equal to 2x plus 3. This is our equation in mx plus b form, slope-intercept form. So our slope is 2, which is 2 over 1, and our intercept is 3, y-intercept is 3, which is x0, y3. Y-intercept is intersection with y-axis right here. Slope is up 2 over 1. If I go up 2 over 1, we are already at the end of the graph, so we can also go backwards, down to left 1, down to left 1. So I can find other points down to left 1. After finding enough points, we can graph the line passing through these points. Equation of this line is y is equal to 2x plus 3. I'll also write a check step for it. To do my check step, I select a random point from the graph, and our y-intercept was 3. I chose a point on the graph where the coordinates were positive. So I chose 1 and 5, so I don't have to deal with so many negatives. And I substitute this value into my original equation and expect to find a true result. If I do not find a true result at the end of my original equation, it may mean a couple things. It may mean that we got this equation incorrectly, or we got the slope or y-intercept incorrectly, and then we might have ended up with the wrong graph. If you end up with a true result at the check on the original equation, that means everything was correct. Here's your next U-try. Let me tell you a joke while you're working on this U-try as well. How do you make 1 vanish? You add a G at the beginning. Here are our next 2 U-tries, and before I let you graph these, I want to show you an example first. This is an example of a special case. You will either have a Hoy situation or a Vux situation. A Hoy situation is a horizontal line, 0 slope, and y is equal to a number is the equation. And Vux situation is a vertical line, undefined slope, and x is equal to a number is the equation of the line. If I were to have y is equal to 4, I would graph y is equal to 4 as a horizontal line passing through 4, and equation of the line would be y is equal to 4. This is for this example right here. If I were to have x is equal to 4, then I will end up drawing a vertical graph at 4, and up and down passing through 4, undefined slope. Equation of this line would be x is equal to 4, and this is the example for this one. Now go ahead and solve or graph these two as your last 2 U-tries onto 2 different graphs. That's pretty much it. If you have any questions, please make sure to bring them to the class.